everybody. Let's continue our look at trees. So yesterday, we started with this idea that the tree is an extension of these advanced, okay, or this is the idea of the ADT, okay? Sometimes it's said it's the advanced data type. More accurately, it's the abstract data types. Abstract being that these things are not locked in like variables and arrays, that these things grow and shrink and are dynamic with the program, okay? So these are abstract data types. So we're extending on, like we did the linked list, and we kind of went through different versions of that, then the stack and the queue, and now we're kind of going to the next level with the tree object, that the tree object is not linear, but instead follows a sort of branching structure. Just like a tree itself, it branches out. And we talked a little bit about some of the terminology there, like all these little terms that we came up with. So there was stuff that we talked about, like that trees use nodes, but it's not going to be the same node as the linked list because it's not going to go to back and front. It's going to go to left and right, okay? That there are branches, okay? That there are parents and children. So there's like this parent-child relationship happening there, right? And that's pretty simple to see in sort of a general idea. That we had the idea of in degree and out degree. And that's specific to each node, that it has a certain number of inputs and outputs. What else? We talked about a lot of that stuff, right? We talked about that trees are based on subtrees that maintain the same property as the tree itself, that a subtree is also part of the same sort of general idea, okay? You can see here we did kind of get the general idea of this down, okay? We also talked about the specific types of nodes, that there are leaf nodes and there are root nodes in a tree. Well, there's actually a root node one, okay? There isn't really a name given for nodes in the middle, okay? They just are generally called nodes. But like you can see that that's a leaf node, right? That one's a leaf node, and that one is the root node, right? Etc. So we got the terms down, and we started programming with generics. However, for this to work, especially when we look at the tree that we're going to be required to learn, which is the binary tree. Binary, of course, means 2. That the binary tree holds certain properties, okay? So what I want you to do right now is give me a list of, say, 5 or 6 random numbers. Please don't put them in order. 42. Come on. 16, 7, 6, 972. One more. Make it negative. No, don't. One more, quick. 53. Okay. We'll make the 6 negative, just for fun. Okay. Now let's imagine that's the order in which these numbers came to us. When you build a binary tree, it will build it based on the order it gets them, but it builds them in a very specific way, okay? So as you would imagine, the 42 is built as the root, okay? It's the first node, so it's going to be the root. Now the 16 comes to us. Where do we put it? We can put it on the left, or we can put it on the right. It doesn't matter. Now you'd think it's random, or maybe we always go left to right, but we don't. With a binary tree, the way it works is, if the next number I'm getting is less than this number, then it goes to the left. And 16 is less than 42. So it goes there. Now I go to the next number, 7. But I always start at the root. So is 7 less than 42? So it's going to go to the left. But it doesn't replace this node. It does the same thing. Is 7 less than 16? Yes. So it goes to the left of 16. Now I get negative 6. Negative 6 is less than this, and less than this. So negative 6 goes here. Now I get 972. Starting at the root, 972 is greater. So it goes there. Then I get 53. Well, 53 is greater than 42, but it's less than that. So this is the shape of the tree it would draw. Mika. What if you get another 42? Generally with trees, they sometimes don't allow equals. That's one thing you can code. Or it will generally consider it either less than or greater than. As a programmer, that's up to you. Generally, I find most programmers put it as less than or equal to. So the 42 would have gone that way. That's an excellent question. But here's a neat point. What if these same numbers came in a different order, right? So I'm just going to take the tree we drew and shrink it down a little bit. So just shrink it off to the corner there. Now, can I actually adjust these numbers? Oh, I wish I could. Let me just break this apart. Okay. Six. Okay. So now I'm going to reorder these. I'll just randomly just mix them up. What happened there? Okay, so. Okay, so let's say they came to us in this order. Okay, what would the tree look like? Okay, so I'm just going to pause my recording for a sec. So this is not that difficult, I hope, especially if you practice it a couple times, to understand that trees will be built, binary trees, based on this basic structure. But for this to work, we have to compare using less than or greater than. And with integers, that's easy. But as we were just talking about, with other data types, this is a little more challenging. So I don't want you guys to code this, but I just want you to watch what I've set up here. I've set up a little demo in main here. And the demo goes like this. I'm going to output what x is. I'm going to output what y is. And if x is greater than y, I will output that. Now I'm doing this using something called the compare to method. Okay? Now, we've talked about how equals is built into every single Java object, and that's true. And I also said when you guys write your own Java objects, it's good to override the equals method so that you can determine what's there. Compare to is not in every single Java class, but it's in a lot of them. Because we don't always need to compare two things to see if they're greater or less than. But sometimes we do. And the one that you may have encountered before is the string. So I'm going to make a string A equal to a new string, which I don't have to do. I could just say equals, but I'm going to do it this way using the string constructor. Okay? And I'm going to make string A, A. And I'm going to make string B, B. So which would you imagine is greater than the other before I run the code? Do you think, and actually, sorry, I'm not going to make this A and B. I'm going to make them X and Y. Okay? So which do you think is greater, X or Y? Y. Okay, so you think that B is greater than A. That makes sense. So this code should run. It'll display what X is, and X will be A. It'll display what Y is B. And then it'll use the compare to method to check them. Okay? So let me run this. Now, compare to method is a little bit of a weird method to use. We'll look at the sort of details of it in a second. But let me just run this to confirm our suspicions. And it says that X is greater than Y. Or sorry, X is less than Y. Which is true then, so Y is the bigger one. So A is less than B. That makes sense, that A is less than B. And it's outputted that, so it's outputted this if statement right here. It's compared X to Y. Now the way compare to works, you can see it kind of in action right here, is it returns an integer. So the compare to method returns back a number. If that number is less than 0, then this thing is less than that thing. If the number is greater than 0, as you can see up in this one, then that one is greater than that one. And if it equals 0, then they're equal. So actually, you can use compare to also check if two things are equal. Okay? So, and you can see that in my output here. So let me show you what I mean by that. I'm going to make them equal right now. So I'm going to make them both equal. So there's A and A. X and Y are both equal at this point. And when I run it, it says that. X equals Y. They are equal. Okay? Now, I could have used dot equals there. I could have said if X dot equals Y, and it would have also registered as true. Okay? Now, the neat thing about compare to is it's built into lots of classes. So I could make this string into an integer. Okay? So that's an integer. That's an integer. Okay? I'll make this one 10 and this one 20. And I run it. Works the same way. I can make this into a double. So I make X a double, Y a double. I'll make it 1.0 and 2.0. Run it. Works just fine. So compare to is built into those classes. I could even go with Boolean if I want. Okay? Again, I'm using classes here, not primitive data types. With primitive data types, I wouldn't need compare to. I would just use the little less than and greater than sign. So I'll make this one true and this one false. By the way, which way do you think this is going to go? Do you think true is greater than false? Whoops. So it says X is greater than Y. So yes, so true is greater than false. Yes. Yeah, good call. Now, I can also do this with my own class. Okay? So I actually did that. I made a quick sample class. I didn't want you guys to code this in. It's extremely simple. This is called sample class. All it has is one piece of data. I just happened to make it a string. So I built that into the constructor. When you construct the simple class, just pass it a string. I also overrode the toString method so that it can output itself. But then I also overrode the compare to method, which isn't necessarily overriding anything, because compare to isn't necessarily built into everything. But what I do here is I've defined how you compare two sample classes. And for this, all I did was compare the data, right? But let's say this class was more complex. Let's say it was a class of your construction, and it had in it not just one string, but it had a couple integers. Like maybe it was a class that you had that was like, say you were making a game, and this was your character class. And it had strength and lives and mana. Is that a thing? Mana, right? So you got all this stuff in there. So when you compare two characters, you might have to compare all those things. But then you could still return whether one character is greater than another, right? You come up with what the comparison is. But if I do this, sample class, it should still work because I've overridden the compare to method. So now I'm going to make a sample class X and a sample class Y. Whoops. And it just so happens to take a string. So I'll put an A in there and a B in there. And it'll also work because I've overridden the compare to method. Okay? So I brought this all up for a reason. We are going to need to do this in our node class because of the fact that we're using generics. Okay? So, all is well. I've proven my point, I hope. Whoops. So now, back to our tree node class. We know something that's going to happen is that we will be overriding the integer return method known as compare to. Whoops. And compare to will take another tree node as a parameter. Let's call it, I don't know, the target. No, sorry, the source. This is the source that I'm comparing it to. Okay? And I will have to write that code, what that is. Okay? Now, luckily, it's based on data, right? Whatever data is. But for now, let's just return 0. We'll get to that in a minute. Okay? But we know that's going to need to be a part of our code. That when I compare two objects, I'm going to need to make that happen. Okay? One tree node has to compare to another. It is. Yeah, it is generic. So we don't know how to compare them. Well, we'll compare them based on the data, right? So you're right, it is based on data. So like we'll be doing something like this, data dot compare to. The problem is compare to is not necessarily a part of the data class because we don't know what the data is. So it'd be like that, source dot data, okay? But here you can see it's going to give us an error. It says it can't find compare to. So we got a bit of a problem there. So we have a problem that we're going to need to resolve. Like I said, it's not going to be easy, but we will find a way to do that. So I'm not going to go into all the details of that today. For now, let's just return 0. Okay? All right, and this relates back to, again, that idea of should we do a deep comparison or a shallow comparison, but we'll get there. Okay, so let's do some of the easier stuff now. We've got to build a constructor for this class, okay? Now let's leave the default constructor out for a minute. Default's always going to be one of the easier ones to write. Let's write one of the harder ones. Let's write a tree node that takes t data, tree node left, and tree node right. So let's write that constructor to start. Actually, that's not that hard, is it? I just say this dot data equals data, and this dot left equals left, this dot right equals right. We've done that before. Man, something's going wrong with my copy paste today. Okay, so pretty simple code. Now the reason why I would suggest you write this constructor first is it's going to make our life easier when we write our second constructor for this. And I think you guys will know why if you can sort of plot this out. So the second constructor would be public tree node with just t data. So just like something like this. Now the question is, what do I write for the code for this? I could put the same 3 lines. I could say this dot data equals data, but then I'd have to say this dot left equals null, and this dot right equals null. Or is there another way we can do this? Right. Remember we did this in the previous linked list example? We can just call this same constructor back here. Saves us a little bit of work, okay? And now let's write the default constructor. The default constructor would be just same idea, no parameter, and I just put a null right there. So that's why I might suggest when you're going to write overloaded constructors, start with the big one first, and then you can simplify these other constructors down afterwards. It's just a little less work for you when you do it that way, okay? So now we have 3 ways we can construct a tree node. Now we could make a 4th way that uses only 1, but I don't think that would be useful, to be honest with you. Because is it the left or the right, and it's just So we either make it blank, we make it just with data. So for example, this would be a leaf node, right? A leaf node would be constructed with data and then 2 pointers to null. Or just the root node when we first start, okay? This one could be a node inside the tree that is actually connected to other things. And then this one, I don't even know if we need that one. I don't know if we even need a default constructor here. I think that's possible that we don't. Okay? Now, we have one more method to write in our tree node class. Well, we have to do compare to. We'll get to that in a minute. Okay? But the one that we have to write, believe it or not, is we're going to write an insert method. Public void insert t data. Now this seems weird. Why would the insert method be inside the node class and not like what we're going to build is a tree class that will use the node class? But again, the reason is because every subtree holds the same properties as the main tree. So the node itself has to know how to insert from itself. And think about that from what you guys just did. You inserted from this node, and then when you were here, you inserted from this node, right? When Jack was doing this, he went, okay, 16 goes here. Then when he got to 42, he went, okay, it goes, inserts from here, and then it inserts from here. He was doing that instinctively. But that's what's happening, is you were inserting from the node itself, not from the tree. Well, from the tree as well, but okay. So here's how it works. Okay, the code is simple, but it takes a little bit of thought to get through it. If data, that's the parameter, okay, dot compare to, okay, this dot data, okay. So here's where I'm comparing, and if it is less than 0. So what I'm saying right here on this line of code is I'm saying, is this data, right there, is that data less than the data inside me, right? So I have that parameter, I have that property called data up top there in the defined code. I've also passed it a parameter called data, and I'm checking the two. I'm comparing them, right? I'm comparing this one to that one. And I'm asking, are they less than one another? Okay? So here again, we're running into that problem. At this point, data is generic. Because it's generic, it doesn't know if it has the compare to built into it or not. It doesn't know that it does. So we're going to need to resolve that. So for now, we're going to leave that error. Okay? We're going to leave it just based on the logic that this will work once we resolve that. And this if will obviously have an else if that goes with it that will be essentially the same thing. But I'll say if it's greater than 0. And actually, why don't we say greater than or equal to? So we'll get that out of the way. So if it's greater than or equal to, then I do something else. And this is the exact thing that Jack did when he plotted those nodes. He started at 53 and he said, okay, is 16 less than this node or greater than this node? That's what he was doing. And so as a result, that's what we're trying to code right here. We're trying to code a comparison between the parameter and this. Okay? We're comparing them. Okay, so what happens is, now I would know at this point that I place, and you don't have to put this comment in, but I'm just going to put it in. Place the parameter, okay, into, if it's less than this, right? In other words, if 16 is less than 53, into a left node. It's actually a new left node from the current node, which is this node. That's what I need to do. Think about that, okay? So let's say that the node I'm currently in, say this node that we're constructing, is a 20, okay? So that's what's held inside the field data. Let's say I just passed it inside this parameter, the number 15. So what it does is it compares 15 to 20. And yes, 15 is less than 20. So what it says we're going to be doing is we're going to be constructing a new node to the left of our current node with the 15 in it. That's what it said we should do. And that's exactly right. And similarly down here, in this section, we'll just place it to the right of our current node. Okay, you can grasp that a little bit, I hope. Your silence worries me. All right, so here's how the code goes. I'm going to erase my comment now. Okay? If this dot left equals null. This is an important check to make. I know I'm going to be putting it to the left, but I better check. And that's what Jack did, by the way. Jack did it right here. Not at 16, but let's say when he got to 42. He started here, he goes, 42 less than this? Yes. So he didn't put it there. He first checked to see, is that thing a null? Then he went, is 16 greater, or is 42 greater than 16? Yes. He checked if that spot was open before he built the node there. Right? The check to see if it's null is the check to see, is this an empty spot? If it is an empty spot, this dot left equals a new node, pardon me, a new tree node, and I can use my constructor and place the data inside of it. I can already just use that constructor. So if the left is null, build me a new tree node off the left side of me. Right? This is me, right? Now, here's where it gets weird. With the else statement. What the else statement means is, okay, so I got 42, right? 42 is less than 53. Is this thing a null? No. So because it's not a null, what am I going to do with that 42? Well, here's where the code gets cool. What I do is I say this dot left dot insert the data. What is that I just wrote? Anyone can give a name to what that is? It's recursion, right. Insert is calling insert. So it's now recursively calling it off the left side. So it's going to use that left node in a recursion to place itself after itself. Cool, recursion, okay? By the way, all this if statement will also go in the down here. The only difference is, down here, change these to right. Okay? That's right, right, and right. Now I'm just going to take out a couple brackets just to save space. You do not have to. I'm just doing that because I can zoom in a little bit more. Oops, forgot one. Yeah. Okay. Now we still haven't resolved this compare to thing. Okay? We're going to get to that. We won't get to it today. But we've got a way to resolve that. Because we're using generics, this gets a little more complicated. So we're going to have to jack it up a notch. But the logic is solid, right? We're comparing one to the other, and we'll do this. And by the way, this is probably the trickiest code we're going to write in the tree class at this point. Yes? We're going to go to the right, yeah. Now, it doesn't matter. We could put the equal sign on either one of those. It honestly doesn't matter. Just you need to resolve that as a programmer. Okay, so we'll pick up on this tomorrow. This is cool stuff.